Hello wonderful person, this is Anton, and in this video we're going to be discussing another unusual exoplanets discovered in some of the recent data. But this time it's once again one of these impossible planets that are technically not supposed to exist because of the way we think planets are usually formed. And specifically because this planet is just way too big compared to this star. Yet based on the observations, it's definitely there, and it's actually quite extreme. And so let's discuss why this is so interesting, what we know about these planets so far, and what all of this means. But first, let's start with a brief overview when it comes to exoplanets discovered so far. And while out of thousands and thousands of confirmed exoplanets discovered in the Milky Way, surprisingly only 10% of them seem to be orbiting red dwarfs, also known as M-type stars. Yet when you look at the galaxy as a whole, M-type stars represent the majority of stars. M-type stars are 80% of all stars. And so for some bizarre reason, there's a bit of a discrepancy between the number of planets we find around them compared to what's expected and compared to what's predicted. But according to modern theories, we actually expect mostly terrestrial planets orbiting these M-type stars. As a matter of fact, the majority of terrestrial planets should be orbiting red dwarfs and not other stars. And so far this prediction has been more or less correct. For example, the famous TRAPPIST-1 system contains 7 such planets, with quite a lot of other terrestrial planets predominantly discovered around M-type stars. And that's of course the result of modern predictions when it comes to star formation. Pretty much all of the planetary systems we've seen so far are expected to form from the protoplanetary disk. And normally this disk evolves and even collapses in a very similar fashion, eventually resulting in somewhat similar planets depending on the initial mass of the disk. And so a massive disk with a massive star is going to produce really massive planets. Likewise, a smaller disk is going to produce something smaller and is extremely unlikely to produce a massive planet. And so studies like this from 2023 essentially suggested that gas giants in red dwarf systems seem to be practically impossible, with maybe only about 1.5% of all red dwarfs containing some kind of a relatively giant planet. But the presence of any gas giant around a red dwarf kind of suggests that the standard model of planetary formation may not be entirely correct, because it doesn't really explain how such planets could form. But based on some other theories and some other predictions, we also know that one of the main reasons Earth is the way it is, and one of the main reasons life potentially even formed on Earth, is possibly because of Jupiter. Jupiter possibly set the stage for Earth to become habitable, causing the planet to form in a certain way, to have certain size, certain composition, and even acquire water. There should be some older videos in the description that discuss this in more detail. And so since red dwarfs are unlikely to have these planets, it may also suggest that rocky planets around red dwarfs would unlikely to evolve into Earth-like planets hospitable to extraterrestrial life. Or at least that's basically the hypothesis behind all of this. But surprisingly, in the last few years, this hypothesis may have been proven incorrect several times. And that's because over the years, at least a few planets have been discovered around red dwarfs that seem to be just a little bit too large. So for example, here's a comparison between Sun and Earth, and here's a comparison between a planet known as LHS 3154b and the red dwarf it's orbiting. Here the size of the planet doesn't actually make sense because the star is really small. Or here's actually one of the most extreme cases, Gliese 3512b. Here the mass ratio between the planet and the star is approximately 270. Or basically the star is 270 times more massive than this planet. But if you compare this to the Sun and Jupiter, the ratio is closer to 1050. And so it's not entirely clear how such red dwarfs can produce enormous debris disks, allowing such massive planets to form, which is a kind of a planetary formation anomaly. Here's another example. Gliese 581 seems to also contain a few planets, with at least one of them having a mass similar to Neptune. And here the total mass of planets does not make as much sense because the star is really small, with the star known as Gliese 876 potentially being one of the more extreme examples, and even one of the more intriguing examples, because here we have 4 planets, with at least 2 relatively close to the habitable zone, but one of these planets being approximately 2.3 times mass of Jupiter. Way more massive than expected, because the star, as you can see from this comparison, is much smaller than the Sun. And so over the years, a few of these planets started to create this bizarre anomaly that even today does not have a very good explanation. And now we officially get another planet, but this time even more exciting than before. This is known as TOI 6894b, a planet that seems to be 86% the radius of Jupiter, once again orbiting a red dwarf that's only 20% the mass of the Sun. And this is actually the smallest star we've ever seen to contain any gas giant. As a matter of fact, this planet is so large and the star is so small that when this planet was discovered, it actually produced an enormous dip, or an enormous shadow around the star, making the star dim by approximately 17%. And that's because this planet was discovered by using the transit method. But this transit was absolutely not expected. Researchers have actually never seen such a large dip anywhere, which would essentially suggest that the star is roughly around 320,000 kilometers across, and the planet is 120,000 kilometers, so approximately a third of the size. But we still didn't know its mass until recently. And so in this study, Edward Bryant and the team you see right here discovered as much as possible about this planet by also using the European Southern Observatory's Very Large Telescope in order to figure out its total mass. Here this is using what's known as the transit velocity method using the espresso instrument, which allowed researchers to establish the periodical redshift and blueshift changes as the planet orbits the star. And turns out that it's not that massive. It's approximately half the mass of Saturn, or 17% of Jupiter. But because it's so large, it implies that this planet is very puffy and very extended, which also makes this a perfect candidate for atmospheric studies. Because it becomes such a large object when passing in front of the star, it means that the atmospheric composition of this planet can be easily captured and analyzed by most of the telescopes we usually use for this, including the James Webb. And some of the preliminary observations suggested that this planet seems to be dominated by methane. But there's also potential signs of ammonia, which technically would be the first time we've ever seen ammonia on any exoplanet. But obviously there's still a major mystery. Nobody has any idea how such a tiny star can form such a massive, large planet. And that's because based on a lot of observations of various baby planets and various growing star systems, we generally have certain expectations about what should be produced around what type of a star. And while the smallest stars are expected to have the smallest planets. Yet here we seem to have a giant that makes no sense. Which once again suggests there seems to be some kind of an anomaly, or maybe we just lack general understanding and general knowledge when it comes to planetary formation. But so far, out of 91,000 low-mass stars observed by the TESS telescope, this seems to be the most anomalous example of a really small star with a very, very large planet. A planet of unknown origin. But luckily in the next few months, we're most likely going to have observations from the James Webb Space Telescope that will allow us to see the atmosphere and potentially even the distribution of material inside the atmosphere, offering a few clues about the formation of the planet just based on what we find inside. And so for all we know, maybe this used to be several planets that combined into one, and this whole puffiness comes from the fact that this is just a really hot object that expanded over time following the collision. But even then, this still doesn't make sense because the total mass of the protoplanetary disk would still be a little bit too massive for such a small star. And so until future studies or until future observations, we're unfortunately not going to know how these planets form or why this anomaly seems to exist among several red dwarfs. And so until future studies or until more of these impossible planets, that's all I wanted to mention. Check out some of the previous videos on a similar topic in the description below. Thank you for watching, subscribe, come back tomorrow to learn something else. Maybe support this channel on Patreon that contains a lot of unseen footage and a lot of additional videos. And of course all videos without any ads. Maybe join the channel membership that contains a lot of early access videos. Or support the channel by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.